All right, let's dive into a classic coding problem with one of my absolute favorite tricks. Get ready for the two-pointer hack.
So let me ask you something. Why would you ever use extra memory when you can solve this whole thing in place with just 2 pointers? This is all about working smarter, not harder. Okay, so here's the deal. The problem is simple. Take an array, find all the zeros, and move them to the end. But here's the tricky part. You have to keep the order of all the other numbers exactly the same.
So this is the array we're going to be playing with: 0, 1, 0, 3, 12. And our target, what we want to end up with, is 1, 3, 12, 0, 0. So how do we get there? Let's break it down.
The secret sauce here, the real hack, is the two-pointer technique. Think of it like this. We've got 2 pointers, a fast one, let's call it J, that's going to be our scout, and a slow one, I, that'll be our gatekeeper. And the best part? We only have to walk through the array a single time. That's it.
Okay, enough talk, let's actually see this thing in action. We're going to start both our pointers, I and J, right at the beginning, at index 0.
And we're off. So J, our scout, has one job and one job only: to run ahead and find us a non-zero number. Meanwhile, I, the gatekeeper, is just hanging back, marking the end of our sorted non-zero section, which right now is, well, it's empty.
All right, step 1. Our scout J looks at the first element, index 0. And what does it see? A 0. Nope, not what we're looking for. So the gatekeeper I doesn't move. The scout just moves on to the next spot. Easy enough? Okay, now J is at index 1. It finds a 1. Bingo! That's exactly what we wanted. So it's time for a swap. We swap the element at J with the element at I. The 1 moves to the front, the 0 gets pushed back, and just like that, our first non-zero number is locked in. Now here's the key rule. After every single swap, 2 things happen. First, our gatekeeper I takes 1 step forward, expanding our sorted territory. And second, our scout J keeps on marching forward, looking for the next prize.
And from here, it's basically rinse and repeat. Our scout J gets to index 2, sees a 0, and just keeps going. But then at index 3, it finds a 3. Awesome! It signals back to the gatekeeper I, and bam! We swap them. Now the 3 is right where it belongs.
All right, here comes the final move. The gatekeeper I moves up to index 2. Our scout J is way down at the end of the array now, at index 4, and it finds the 12. One last swap, and there you have it. Our non-zero numbers, 1, 3, and 12, are all lined up at the front, in perfect order.
So now our scout J has finished its journey, which means the loop is over. And just look at that result. It's perfect. All the non-zeros are at the front, still in their original order, and the zeros have been pushed to the back. Mission accomplished.
So that visual is cool and all, but how do you actually write the code for this? You're going to be surprised at how simple it is. Check this out.
Seriously, this is the whole thing. The for loop, that's our scout, J, just marching through the array. The if statement is J asking, hey, is this a non-zero number? If the answer is yes, we do that little 3-line swap with whatever is at our gatekeeper I's position. And then, only then does I get to move forward. That's literally it. It's a perfect translation of what we just watched.
Okay, so you're probably thinking, that's a pretty neat trick, but so what? Why is this such a big deal? Well, let me tell you.
The payoff is absolutely massive. First, time complexity. It's O of n. That just means we go through the array one time and we are done. You literally can't get any faster. But here's the real kicker. Space complexity is O of 1, constant space. That means we use 0, and I mean 0, extra memory. It doesn't matter if the array has 10 elements or 10 million. This is what an optimal solution looks like.
And look, this isn't just some clever party trick. This is a fundamental pattern that interviewers love to see. Why? Because it proves you're thinking about efficiency. It shows you can solve problems without being wasteful. So for real, burn this one into your brain, and definitely save this for your coding interviews.